Let's start with number 153. Find minimum in rotated sorted array. We will have an array in this question and then it will be rotated a few times. Here is an example of it rotating 4 times. So 0 was here, 1, 2, 3, 4. So now it's here. And then we'll have to find the minimum in that array, but we need to do that in big O of log n time. So we cannot follow a linear approach which will give us a big O of n time. So the approach for this is using a binary search. So in binary search we have 3 parameters: a left pointer, a right pointer and a mid pointer. With each iteration we'll check if the left pointer is lesser than the right pointer, because if they cross it means we have traversed the array, and check all the elements. We calculate the midpoint and check if the right side is lesser than the midpoint, then we adjust the midpoint accordingly. We have the lowest element here to the right side of the mid, which is 0. Let's see how to approach this. We'll have a condition while left lesser than right. So is the left lesser than right? Yes. Calculate the mid. The mid should be the floor of left plus right by 2, which is 7 in this case. So if the number on the right, which is 2, less than mid, this is less than mid, we'll push the left as mid plus 1, and then we'll update the midpoint again, which is left plus right by 2, the floor of them, and then we'll check again if the left is lesser than right. Yes. Check if the number on the right is less than the number in the mid, which is wrong here. So what we do is we adjust the right pointer here and make it move to mid. We'll again check left is lesser than right, so we'll adjust the mid to the floor of left plus right by 2, and then we'll check again, is the number on the right lesser than the mid number? No. So we'll adjust right to the mid. And now since this condition is false, we'll return the left or the right pointer, which is both pointing to 0, which is the required minimum element here. So let's write some code. We define the 2 pointers and then our while loop. We'll update the mid and then check if the number on the right is less than the number in the mid. So we'll shift the left to mid plus 1, else make the right pointer come to the mid, and then after the loop ends we'll return, which in this case is the same as nums of right. So everything is accepted. We'll submit. So this is how the binary search works. So with every iteration the search area is halved. That's why it has the time complexity of big O of log n.